Okay, you're welcome to Egrep Pro 163. This is Cisco Certified CyberOps Associate, understanding Cisco Cybersecurity Operation Fundamental, CBR Ops 101. Alright, I want to welcome you to your Egrep Pro 163 channel to master cybersecurity. Get ready to dive deep into hands-on lab experience, tackling the real-world challenges and exam scenarios with detailed explanations and step-by-step guidance, building the skills and confidence needed to excel. Join our community of aspiring cybersecurity professionals. Let's make the future of digital security together. So subscribe, stay engaged. Let's get started on this journey to become a cybersecurity expert. Alright, today's lab is going to focus on investigating data exfiltration using DNS. Let's quickly talk about DNS. DNS, domain name server, are directories of domain names, and they translate the domain names into IP addresses. This service can be used to exfiltrate data. So in this lab, we will use the DNS service to facilitate data exfiltrations, and then we are going to analyze the exfiltrations of the data. Alright, domain names were created to convert numeric IP addresses into a simple and recognizable names. So fully qualified domain names such as Cisco.coms are much easier for people to remember than the numeric IP address like 198.133.219.25. So it's easy for us to always remember the fully qualified domain names. More reason why we have the DNS to always match the fully qualified domain name with an IP address. So the DNS protocol defines an automated service that matches the resource names with the required numeric network address. It includes a format for queries, for responses, and data. Alright, so the DNS servers store different types of resource records that are used to resolve names. These records contain the names, the address, the types of records. So some of these records is A record, the NS record, the AAA record, the MS records. So when a client actually makes a query, the server, the DNS, the processes first look at his own record to resolve the names, and if he's unable to resolve the names, by using his stored records, he contacts other servers to resolve the names. And after a match is found, it returns to the original requesting servers. So the server temporarily stores this numbered address in the event that the same names is requested again. So we always have a cache on our local workstations for the DNS records. So anytime we actually request for a name resolutions, as in for the IP name resolutions of the DNS, it keeps that. So next time you're trying to do the name resolution, instead of doing the queries again, it quickly responds to that from the cache. And then we also used to have a local DNS. And our local DNS try to make queries with other DNS, look up to other DNS in order to do name resolution. Alright, so this DNS uses a hierarchical system to create a database to provide name resolution. And each DNS server maintains a specific database files and is only responsible for managing name to IP mapping for that small portions of the entire DNS structures. So we have these DNS hierarchy structures, and from the root level, top level, second level domain. So the top levels are .net, .edu, .com, .au, .co, .uk, and so on. So these are top levels, and then we have the second level. It can be maybe Cisco.com. So it keeps a record in this hierarchical structures. It uses this hierarchical structure to create a kind of database to provide name resolutions. These are lab. So our lab topology, and so it's structured in the sense that we have four workstation, here. So we have the Kali, which is acting as the internet host, external host, the attacking system, and then we have the internal host, which is the CyberOps. So the CyberOps happen to have a confidential files that the Kali is going to attack. So the attacker is going to exfiltrate from the inside host. So we have a confidential files in this CyberOps. Then this CyberOps, the local DNS server of the CyberOps is on the vulnerable servers, which is the Metasploitable. So this Metasploitable happens to be our DNS server as well. Then we now have the fourth workstation, which is security owner. So the security owner actually acting as a router. Reason is because is the one providing an interface for all these workstations to be able to communicate together, to interact together. So this security onion, we also have the tools that we are going to use for analysis. So it keeps all the records of what is going through and flow of from the Kali to the Metasploitable and to the CyberOps workstations. So we're coming back to this security onion to do analysis. So it happens to be the device that is acting as a router as well as firewall and also our security device. Okay. Alright, so let me quickly bring them up. So I have my Kali workstation. Okay, so the first thing I will do now is to first of all locate where I have my file. Okay, so I'll go to the directory where I have my confidential file. So I'll do change directory cd lab.support.files. Okay, then let me list what I have in this directory. So you can see I have this file here, confidential. Okay, so in this confidential, I quickly open what we have there to see what we have in that. So by using cat confidential, right? So you can see that I have this confidential document. Okay, so we assume that this is a confidential file, right? And this is a file that we want to exfiltrate. So what most things the attackers always do is to, what we can do most times, what they do is to convert this to an hexadecimal value and then append it into the DNS logs, query logs, and then exfiltrate from there. So that's what we're going to do. So in order for us to convert this to an hexadecimal form, for us to be able to exfiltrate it, so we use SSD, XXD. So we can then first of all do man XXD. So we use this SSD to convert files, text files to hexadecimal file, and also to reverse. So you can see H to H dump or do the reverse, right? Then I have some options I'm going to add by -p, so which is for PostScript. Okay, so we'll make it to be a PostScript format. All right. So from here, so I can quickly say SSD -p, and the file is confidential. .txt. Then I will output the file to confidential, and then the extension is going to be HES. Okay, so that will be our new file. So confidential is all right. So okay, good. So from here now, I should be able to see that I now have a file called confidential.hes. So let's list our files again. So listing our file, you can see now we have this. So let's open that file. Cat confidential.hes. Alright, so now I have the hexadecimal value for this file now. Alright, so we are going to prepend this file into the DNS query logs. Alright, so that's the next thing to do, but then we need to find out what is our DNS address. So we can get that information on the etc files. Under the etc directory, then we have the resolve.configuration, the DNS configuration files. So I'll quickly go to open that file, cat, then you say cat/etc/resolved.config. So you can see our DNS configuration file, resolve configuration file. So here we can see the address of our DNS 209.165.200. So this is the local DNS address. Alright, good. Since now that we know the local DNS address, so the next step is for us to prepend this into a DNS query logs. And then what do we use for that? We're going to use patch for loop to do that. Okay, so let me quickly explain the command for us. So we're going to have a batch for loop. So this cat will actually open the cat to open the confidential.hes. Now this is a file, it has 4 lines. So what is going to do that is we are going to add each of those lines, going to add ns.example.com to that line. So the drill is a command that is designed to get information out of DNS. Use that command to get information out of DNS. And in each of those lines, now going to add ns.example.com. So that's what this command is going to do. Right. So then take note that this backtick is actually the one beside our one, the keyboard on the keyboard, the one beside the one on the keyboard, not the normal quoted sign. Okay, so we go back to the workstation. Okay, so I'll have to make sure that I type this correctly, so let's quickly copy this. Alright, good. So I have this now. So if you look down here, so you can see that these are each of the hexadecimal values. So this happens to be the first one, and ns.example.com must be added to it. Okay, so each of them. So I have this first one here, and this is the second one, 3.example.com, and I have the third one here, 72.example.com, and the fourth one, 608. Good. So now that we have this in our records, in our DNS query logs, so we have already prepared this content into the DNS query logs. So the next step is to use the Kali now to exfiltrate that from the query, from the DNS, exfiltrate that data from that DNS query logs. So I'm going to the Kali now, and so for Kali, for us to do this, so which means that we have to remotely log into the DNS, exfiltrate it from the DNS server, somewhere in the DNS server, then we now remotely copy it into the Kali. So that's what we're going to do. So the next thing here on the Kali, so I'll remotely connect to the DNS server using secure shell. So SSH. I know that then I have to have a credentials. I must have a valid credentials. So already you know that the Metasploitable has a user account. Okay, so we're going to use that, and then at the address. What's the address? 209.165. As we can see here, 165.200.235. Okay. Alright, so I'll put in the password. Yes, now I'm in. So you can see the prompt now is users as Metasploitable. Alright, so what are we going to use to exfiltrate this from the DNS? So we use Egrep. Egrep is also a command, so we can quickly say man Egrep. So we use Egrep to match the characters that we have on that query. If you want to match any characters of content, you want to print out, you want to match some specific characters, you can use Egrep. So we're going to match those content of in our DNS query logs. We match those ones that has to do with the specific characters. So we are going to specify the hexadecimal values. So like we know that they are already in hexadecimal values, so that's why we specify maybe A to F, 1 to 9. We know the hexadecimal, that hexadecimal is from 0 to F. So we need to match all those characters. So we say that inside this log, inside this query logs, match these specific characters and then pull out the informations that match these characters. So that's what this Egrep is going to do, right? So you can see that it print lines matching a pattern. So the pattern we're going to specify is going to match it and print it out. Okay, so let me quickly explain some of the syntax we're going to put in there. So we have this. So we're going to say Egrep -o happen to be an options to display only the matching portion. So we want it to only give us those matching portion, and our matching portion is from 0. You can see from 0 to 9A to F. Those are hexadecimal values that we want to match, and that ended with what? ns.example.com. We're getting it. And where do we have this file? This file, where we wanted to get the file from, is var_lib bin query.logs. So this is a part to our log files, to the query file. Then we can see then we use cut command to remove the sections from each lines of the files. So the cut -d-f1 commands use the period dot as the delimiters to keep only the subdomains and remove the rest of the lines with a fully qualified domain name. So it's going to remove all those other fully qualified domain names, ns.example.com. It's going to remove all that. And the nick, this nick is a command that remove any duplicates. So this one is going to remove all the duplicates and duplicate ones that are there. Alright, then okay, so then we have this pipe which takes the output of the command to its left, which comes in the input to the command on the right of the pipe. So we have two of them there. So we're going to have this now. So all what the output is going to secure 1.hes. So that's what we're going to save our file as. Okay, so we'll change this to 1. Right, so then So let's try to do that now into the command. Okay. Right now, so let's list. So here's the list now. So you can see now we now have this secret.hus. Okay, so now that we have this file secret.hus, so let's open what we have there. So you can do cat secret. Okay, so you can see the hexadecimal files now that we have from the beginning. Right, so yes, I have all this because I've repeated it. Alright, so fine. Now that we have this hexadecimal value, but now we only have this save somewhere on the Metasploit. You can see that we are seeing the Metasploitable. So the prompt is seeing the user. So it's a user under Metasploitable. That's where we have the file. So how do we extract? So we need to take this file into the so we need to take it into the Kali. And so we're going to exit from here, and then after exit, then we can now copy. So we do secure copy to the Metasploitable by copying this file into the Kali SCP. Then so we know that it's under the user account. Then user account at the IP address of our DNS server, which is the Metasploitable 165.200.235. Then colon, so the location of where we have the file. So we have it as slash. So it's on the home directory of the user. /user, and then the name of the file, which is the secret. Oh, secret.hus, right? Okay. Then space. So where we want it to, where we want to put it on the Kali there. So we want to put it on the home directory of this Kali where we are now. So we have this home sign. This is just the home sign, and slash. So it's going to copy here into the home directory of the Kali, of the Kali, yeah. And then enter. Right. So wait for it to copy. Okay. So put the password. All right, good. So now we now have this file here. So we have copied it to Kali now. So let's quickly verify that by saying ls. So we can have ls. So you can see the secret.hus. So let's see whether it's what we have in the Metasploitable. So we can quickly open that cat secret. All right. Okay, so you can see that it's the same thing that we have now. So we have successfully copied this into Kali. So what next they will do is to convert it to test file so that they can see what is there. Okay, so and how do we do that? So we're still going to use the same SSD. So everybody know how that this SSD is used to convert from hexadecimal to test file, from test file to hexadecimal, right? So that's why we, as a analyst, we also need to know how to use these tools to be able to convert and then reverse all these test files from test files to hexadecimal, to know the trick that they use for all these data exfiltrations, and then know how to use all these tools. Okay, so I will use SSD, right? Then use the reverse. Now we are doing a reverse. That's from the hexadecimal to hexadecimal file to test file. So I will, in that case, we'll use -r and then -b. So we are going to use those two options, and the names of our file, which is secret dot HES. And so we output the file to, I'll call it secret.text file here now. Okay, so we're changing it to secret.text file. Good. So what we have, so we have it now. So let's see whether we now have the file called secret.txt. Okay, so you can see that we have this secret.txt now. So can we open that? Let's see, cat secret.txt. Alright, so can you see confidential document? This document contains information about the security breach. Okay, right, so good now. So we have this. So they have successfully, exfiltrate this data into Kali. We said the Kali is our attacking machine. So this data, and they have seen what is inside the confidential file. So now we are moving into the analysis. How do we be able to know what has happened? How do we know the kind of file they have, the kind of content of the file they have exfiltrated from the server? So we're going into the analysis. So we're going to use security onion. Like we said, that security onion, routing device, and also our security device, monitoring what is going on the network. Alright, so we're going to use this. We have this ELSA. ELSA happens to be our enterprise logs search and archive. So it provides solution for index logs, and then also provide a kind of simple and a clear search interface, so we can be able to see all what is going on each of those protocols. So we can go to the DNS and check what we have there, and then we can use it for reports, for sharing logs. So we also have like a plugin systems that can take actions with those logs. Right, so I'll quickly go to the ELSA now. So let me log in. Right, so like I said, it gives us a very clear search interface. So as you can see, each of those protocols. So we want to investigate the DNS. Okay, so we can click down to the DNS. So all the queries that goes on the bottom of the queries of the DNS. So I click on the bottoms of the DNS. Right, so now seeing something like this, you can see 443, you can see hexadecimal combined with our named records. This is a kind of a sign of a malicious activities. So when we have a domain names are not statutory byte hexadecimal expressions. They are not in all these expressions. So this could signal a kind of a malicious activities, because user probably cannot remember a long subdomain names like this. So user cannot remember. So seeing something like this is already showing us that a kind of a malicious activities has taken place. So what we can do is to verify more and see what is inside, and then we can do some conversion. We reverse this hexadecimal to a text file and see what is there. I will click on the on this first one here now. So we convert them one by one like that. Okay, so I click on this now. So what are we going to do? So I can then I'll copy the same files again to get copy the hexadecimal values there, and then I can use echo to see what is there. So I use echo together with xxd. So you can say echo, then I'll use -n. We use echo to display the lines of the text, then we can use the option -n not to output the trailing nail lines. So we can put -n together, then we'll quote the hexadecimal value, Then I'll put my pi and then SSD. So we know we are doing reverse, so that will be -r, and then that's because it's also in a PostScript format, so put -p. Right, so let's see what we have. So you can see that now it's showing confidential, do not. Okay, so that's one. And I can go back and see by the time we reverse, you have to just keep doing that one by one to get kind of information that's going on. So you can go back again. Right, so take the next one and see after this. So copy this again. So you have to do them one by one to see what kind of using the same. Sorry, and so you can see. So I have confidential, do not. So these happen to be formations about the last secure. Okay. So by the time we continue, so let's do the fourth one. Back there. So this we've done this, so we're taking this now. Okay. Okay, you can see. So these happen to be formations about. Okay. So this document contain. So that's how we at least have a clue of what has happened. So this is just to give us a clue of what kind of information that has been extracted from the through the DNS. And then in this our ELSA here, so if you look at the ELSA, you will see that we can as well download. So I can go down to information. I can go to information to get more information. So then use the plugin, get the data files, and log into this analysis. So you get this. Now, if you look at it, you can see that I have the information of my source IP address, the destination IP address. So this can help us to be able to, we can download this for further investigation, for thorough investigation. So we can download the picker files for reports as well for also thorough investigations. Okay, so look at it now. So you can see. So I can download this picker files. You can see here. Click on it, download the picker files. And also open with Check. So all these are informations that we need to put down. So we can see the port address. Here now we have the timestamp of when the event took place, the source IP address, the destination IP address, what's the port numbers, DNS. So we keep all these records for our reports. Right, so that's just all. That's a quick one about this for this investigation. So you can you can go ahead and open this with Wireshark for more other investigations. So at least seeing something like that we can always see that it's a malicious activity. So DNS record is not always in hexadecimal form like that. So for us to see that, it's a signal that is a kind of malicious activities has taken place. So that's all for that. I want to thank you for viewing. So like, comment, share, subscribe, and thank you for watching. We will see you in another edition.